So remember that the unit circle is a circle with a radius of 1 centered at the origin. So our unit circle is a circle with a radius of 1. And center at the origin. What we want to know are the angles in standard position and the coordinates on the unit circle of each of the angles in standard position. So I want angles I want to know angles in standard position and coordinates on the unit circle for the quadrant angles and anything with a 30, 45, or 60 degree reference angle. I want to know the angles in standard position and the coordinates on the unit circle for all these angles, the quadrant angles and anything with a 30, 45, or 60 degree reference angle. I want to be able to name the angle and I want to be able to name the coordinates on the unit circle of radius 1. And I want to know this for all 4 quadrants. The way we go about sorting this out is we make our unit circle with a radius of 1 and we find out what half of the radius is. So I really have 2 circles here. We can't really see the middle one. A radius of 1/2 and a radius of 1. The reason that we want to know these 1/2s is that 30 and 60 both involve a 1/2. So if we go 1/2 on the y's, that's how we find our 30 degree reference angles. We find our 30 degree reference angle when y is equal to 1/2. We find a 60 degree reference angle when x is equal to 1/2. That's why we want to make sure that we find out where those 1/2s are. Next, we want to know what these are paired up with. So we want to know that we have a 30 degree angle here. And the coordinates there are, the y coordinate is 1/2. The x coordinate that we found last week, instead of having 1/2, the x coordinate is going to be √3/2. So those are the two that go together, a 1/2 and a √3/2. So the coordinates at 30 degrees are x is √3/2 and y is 1/2. A 30-degree reference angle in quadrant 2 is 150 degrees. Here, the x-coordinate is negative, so I'll have a negative √3/2, and y is still 1/2. That's how we found this place in the first place. 30-degree reference angle, y-coordinate of 1/2. The other coordinate that goes with a 1/2 is a √3/2. Everybody remember from last week? On the test that I had in like 5 minutes. I'm just kidding. The test is in 10 minutes. Just kidding. There are no unannounced tests. But sometimes the length of time between the announcement and the application is very short. Something like, oh, let's have a test. And not hand it to you. You know, I thought there were no unannounced tests. And I'll be like, oh, I just announced it. And I go, dude, that is not fair. I go, you're right, that isn't fair. Yeah, 10 minutes, go. That'd be messed up. Funny. What needs to happen is real surprise tests. But you know, for the most part, you're only going to have math tests when you go into math class, right? So maybe there's a pop quiz in math, right? But you always know, at least partially, when that pop quiz is going to show up, right? You're going to be in math class. But what if it didn't have to take place in math? What if you're just in line getting fucking coffee? You know, like I'll have a large black coffee and you'll be out there like, oh great, here's your receipt. It's like, oh, I don't need a receipt. Your receipt is actually a math quiz, but your barista is actually Professor Leach. I'm like, well, go do that, then you'll get your coffee. That would be a pop quiz. Go out to make breakfast in the morning. It's like whenever you get up, it's like 6 o'clock in the morning. Oh man, I hope I have a pop quiz in math today. And I'd be like in your kitchen, like, oh, good news, you don't have a pop quiz in math. You have a pop quiz in your fucking kitchen. It's on the fridge. I didn't have enough time to escape. Go. Coming home from work, putting the keys in the door. All of a sudden, an arrow just comes flying out of nowhere. It's like, shunk, hits the door jamb right next to you. And they're like, whoa, what is this? There's like a piece of paper tied to it. So you undo some string and pull off a piece of paper. And it's like a math quiz. And I'm like, what the? And I'm like off in the distance. Pop quiz. You got 10 minutes. And I've got lots more arrows. I'm just kidding. I don't do that anymore. I'm just kidding. I never did that anybody could find out about. I'm just kidding. Someone did find out about it, so I did 2 holes in the desert that day. I'm just kidding. It was 3. What's 30 degrees in the third quadrant? -10. And the coordinates there, the x coordinate, notice that in the third quadrant, x is negative and y is negative. So my x coordinate is still negative √3/2. But my y coordinate is now negative as well, so negative 1/2. What's 30 degrees in the fourth quadrant? That took too long. It's 330. Notice that in the fourth quadrant, x is positive and y is negative. The 30-degree reference angles happen when y is 1/2. On the unit circle, if y is 1/2, then x is √3/2. Notice that in all these, y is 1/2 or negative 1/2. That's how we found the 30-degree reference angles in the first place. 60 is when we have x equal to 1/2. So at 60 degrees, the x is equal to 1/2, and the y is going to be the √3/2, because those are the two that go together because we use the Pythagorean theorem to find that out. So here, x is positive 1/2, and y is positive √3/2, because in the first quadrant, x is positive and y is positive. What's 60 degrees in quadrant 2? 120. In quadrant 2, x is negative and y is positive. So now the x has still a 1/2 numerical absolute value, but it's a negative 1/2. So negative 1/2. And y is positive at √3/2, because those are the ones that go together. Sixty degrees in the third quadrant is 240. In the third quadrant, x is negative and y is negative. So both of these coordinates are going to be negative. We found this by making x negative 1/2. So the y is negative √3/2, and x is negative 1/2. In the fourth quadrant, x is positive and y is negative. Two coordinates times two signs, 4 choices. So there are our 4 quadrants. 30-degree reference angle happens when y is 1/2. 60-degree reference angle happens when x is 1/2. When y is 1/2, x is √3/2. When x is 1/2, y is √3/2. And at this point, you're like, oh, we know this. This is what you said last week, and you said it a bunch of times then. And I'm just going to remind you, you don't get songs stuck in your head hearing them once. You get songs stuck in your head because you hear them all the time. But the only radio play that I get during class twice a week for 2 hours, so it has to be constant. Okay. Everybody's got all these points memorized, right? Good question. You didn't have to memorize them. You just have to remember them. All of them. It only seems like a lot to remember because it's a lot to remember. You have to remember all of it. All the time. We have to know our quadrant angles as well. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back up to the top at 360. At least the coordinates there are easier to remember. It's just the zeros and the ones. Okay. Now, one of the things that we can do with this, remember what we're trying to do is get an idea, learn this map of the unit circle. Right now, we've got the 30, 60, 90 unit version of the unit circle. 45 will come later. But we've taken each quadrant and broken it up into thirds, 30, 60, and 90. The next one, we're going to break each quadrant up in half, 45, 90. Right now, I've got 30, 60, 90, 60, 30, 0. Here's another way that we can organize this information. I'm going to take theta and run it horizontally. Instead of having theta go run around in a circle, I'm going to run theta horizontally. And then I'm going to run just the x coordinate vertically and then the y coordinate vertically. So let's see what that looks like. So we're going to draw a vertical axis, kind of cheat your vertical axis over to the left. And you're going to want to make sure that you have a good location on where's a half, negative a half, and do I want to make it that big? I guess the question is, do I want to do both? Let's just do one. So on my vertical axis, I'm going to have the middle at 0. And I'm going to make sure I can locate a half and then 1. That's going to correspond to the 1/2 and then the 1 on the radius. That's why I want those to be easy to find. And that's what my vertical axis is going to look like. My horizontal axis, I'm going to want to count in thirds. Notice that I've broken up each quadrant into thirds. So we're going to want to count by thirds. So down here, that's going to be my first quadrant. I'm going to break it up into thirds, 30, 60, 90. And 30 or 60, 30, 180. So I'm going to mark 1, 2, 3. Then I'm going to mark 1, 2, 3, and I'll be back at 360. So notice my horizontal axis is going to be is theta, but instead of going around in a circle, I'm stretching my theta horizontally. Then I'm going to try to draw a horizontal line. So I'm putting theta on my horizontal axis. And it's going to get super crowded as the numbers get to 3 digits long. But we got the color coding. So I'm just lined up my thetas horizontally, but we can still see each of the 4 quadrants. We can still see where each of the 4 quadrants are. Here's our first quadrant. Here's our second quadrant from 90 to 180. Here's our third quadrant from 180 to 270. And here's our fourth quadrant. Notice that close to the 90, since 90 is up here at the top, close to the 90 is the 60 and 120. So there's the 60 and the 120. The 60 and the 120 are close to the 90, and close to the 270 are the 240 and the 300, the 260-degree reference angles. Close to 180 and then 0 or 360 are where the 30-degree reference angles are. So you can see those red ones bunched up around 180 and around 0 and 360. But I'm dividing each quadrant into thirds So I've got 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Any questions? I'm just taking theta and I'm spreading it out across the line. Now I'm going to go around and I'm going to plot the x coordinate at each of those thetas, not the x and y, just the x coordinate. So my vertical axis is going to be the x-axis And I'm just going to track the x values around the circle at 30-degree intervals. X starts off at 1, so I'll start off up here. The other easy ones to find is that x drops down to 0 at 90, and then down to -1 at 180, then back up to 0 at 270, and then back up to 1 at 360. So we see this down and then up, from 1 to 0 to -1 to 0 to 1. That down and up. That's a low resolution down and up. Game Boy Advanced resolution. TI-84 resolution. You only got to mark every 90 degrees. That's not very good. Let's put in some more points. The important points that we want to find here, the hard ones to find, the easy ones to find are when we get to a half. So notice that are the two values I'm going to be looking for are √3/2 plus or minus and 1/2 plus or minus. √3/2 is approximately 0.8660. That sounds like a pain in the ass to find. 1/2, that sounds easy to find. So that's the one we want to find. The 1/2s happen, the x coordinate of 1/2 happens at 60 degrees, 120, 240, and 300. So now I've got a little bit better resolution on my down and then up. At a 60-degree reference angle, we'll be at a half because we're looking at the x coordinate. 60-degree reference angle happens when x is equal to 1/2, and that's what we're trying to graph. X is equal to 1/2. 60-degree reference angle, x is equal to 1/2. 60-degree reference angle, x is equal to 1/2. 60-degree reference angle, x is equal to -1/2. 60-degree reference angle, x is equal to +1/2. Now we get a little bit more resolution. We see going from 1 down to 1/2 takes longer than going from 1/2 down to 0. See how it gets steeper from 60 to 90 than it was from 0 to 60. It's kind of shallow and then it gets steeper. So in the roller coaster, this is people when the screaming up here is anticipation. Then the screaming in here is kind of like slowly accelerating, and here we're kind of moving fastest. So here's when people are going, yay! And then it starts to fade as it slows down, because from 0 to -1/2 is pretty fast. And then from -1/2 to 1 takes twice as long. Notice how we go from 0 to -1/2 in 30 degrees, but go from -1/2 to -1 takes 60 degrees. And now it's like, oh, click, 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 click. It's not as exciting because it's going up. That's the boring part of the roller coaster. Any questions? So first, we locate the general shape. 1, 0, -1, 0, 1. Then we find our halfway marks. Since I'm tracking the x coordinates, I'm going to mark off where we get our 1/2s are going to happen at the 60-degree reference angle. Now we want to get a little more detail. So in between our 1/2 and -1/2, and then our -1/2 and 1/2, We can almost connect these with a line. So I just want you to make a dotted line between on these two inside points. Connect those with a dotted line. Connect those, the 1/2s, the 1/2 to the negative 1/2, and the negative 1/2 to the 1/2. Just connect those with a nice dotted line. At the top and the bottom, things have to flatten out. That's where the graph has to turn around. Where the graph is turning around. So I want you to draw short little flat segments at the top. Not extensive, just kind of flat. Just remind yourself that these things need to flatten out. Flat at the top, little flats at the bottom. Now we're going to connect the top to those those dotted lines with curvy bits that are going to start off curvy at the top and then gradually bend to meet up with the line parts. So we're going to start off flat up here. I'm just going to bend the graph down until it matches up. It lands at the same point and it's going in the same direction. That's what we want. It wants to land at the same point and it wants to be going in the same direction. So I don't want a little corner here. Start off flat, bend it so that it lands at the same point and it's going in the same direction. Then you do that for all the other ones. Start off flat down at the bottom and bend it so that we're going in the same direction and we land at the same points. Want it nice and flat at the top, then we want to bend it so that it lands in the same place and is going in the same direction. I want you to think of those two things. It's the same place, it goes in the same direction. Same place, same direction. It doesn't have to be perfect unless at some point you want to graduate from college. I'm just kidding. We're just sketching stuff. See all the dotted lines? See how many dotted lines? Bob Ross style. No mistakes. Doesn't have to be perfect. We want to hit the same point, go in the same direction. Start off flat. Make sure we get flat by the time we get to the top. Because once we get to the top, we're going to be turning around. So it's got to go flat so I can go back and do the same thing. We want this nice graph where it flows down, and up, and then down, and then up, and then down, up. The graph is good. The graph into the soul, where it burns a hole in the like a passion from a bleeding sizzling on the floor as it melts to the planet. And we start to wonder who's in the floor below us. Well, we're about to find out. But the acid is still burning up. Maybe I shouldn't do those kinds of things. What we're trying to do is learn the unit circle from 0 to 360 degrees Because once we know what's going on from 0 to 360 degrees, we know what's going on everywhere. Because once we get here, it just does the same thing over again. 1/2, so this is 30 degrees after, so 390. And then if 420, that's when we hit 1/2 again. It's just going to be a copy. And then it's going to be roughly a line from this 1/2, 30 degrees down to 0, 30 degrees down to 0 to negative 1/2. Make sure it's about linear. It's technically not linear, but it's very close to being linear. And then it's going to take 60 degrees to get down to the bottom. And then the same thing is happening before 0, because we're just going around the circle from your perspective, just going around the circle. 0 to 360 is the same as 360 to 720 to 3 times 360. I don't know how to skate, so I don't know my multiples of 360. Questions? Is everybody okay? So we can't just use a computer to generate the graph, but the graph is not the point. The construction of the graph, that's the point. We're trying to learn the unit circle going around. And so we're looking for the patterns that we can find. We're trying to connect this flowing graph with imagining going around the circle. So tracking it, so at this point here, 0. At 0 degrees, the x-coordinate is 1. At 30 degrees, the x-coordinate is √3/2. So at 30 degrees, this is about where 0.8660 is. That would have been hard to find on graph paper, square root of 3/2. But I know I got to be flat up here, and I got to be kind of falling into this line by the time I get to 60. So that tells me it's going to be high, a little bit up higher. So rather than plotting all the points, plot the points that are easy to find, and then connect the dots. So we go from 1 to √3/2 to 1/2 down to 0. That's first quadrant. From 0 down to negative 1/2 to negative √3/2 to negative 1. Second quadrant's done. From negative 1, negative √3/2, negative 1/2, 0. Third quadrant done. 1/2, √3/2, 1, and then we're repeating. Everybody okay? So what we did, we plot the quadrants, locate the 1/2, where the reference angles where we have a 1/2. Draw straight line segments between the 1/2s, and then fill in the curvy bits. This is the x running around the unit circle. Starts off at 1, drops to 0, down to negative 1, up to 0, back up to 1, and then repeats. We want to do the same thing for the y coordinates running around the unit circle. So in this case, we're going to be locating the 1/2s at the 30-degree reference angles. So when we make a graph for y, the 1/2s will be at the 30-degree reference angles. So I'm still going to be splitting this up 30, 60, 90. Let's take a break, come back, and then we'll graph the y, and then we'll see how this connect helps us moving forward.